Welcome again to our webinar. So like I said, today we're doing a webinar about IAQ and decarbonization, so retrofits, mostly from steam to adiabatic, and what can we do to make that happen. So joining today is me. My name is Nuno Silva. I'm a business developer for Condair, and then we also have William Truong on the call, also business developer for Condair. Before, both of us used to be product managers for many years, also in Condair group. If you have any questions during the webinar, you can write them on the questions section, and then at the end, we'll read the questions out loud and we'll answer them so everyone can listen to the questions. So if during the slides you have any doubts or any questions, just write them there, and then at the end, we can go through that. So just a bit about humidity, about Condair. So Condair is a humidification company, also dehumidification, and basically we focus on three main areas. So we have productivity, industrial, commercial, like manufacturing, data centers, pharmaceutical, food, etc. Then our second best pillar or second main pillar is health. So hospitals, office, schools, swimming pools, etc. And then we also have another big pillar, so also our three main pillars is value preservation. So that's museums, galleries, artwork, so preservation of materials, so there is no dryness of the materials. So I'll say by this order, we'll say the biggest one will be productivity, industrial, and then health, and then value preservation. Just to show you some of the fields where we are, you can see from education, entertainment, storage, airports, hospitals, data centers. Data centers mostly cooling, evaporative cooling, but also some humidification. And recently also we have a big push for homes and residential segments. But this is to give you an example of what we do worldwide and also more specifically in North America. So just a story about Condair. So actually this year is our 75th anniversary. So we are started in 48 in Switzerland, in Zurich. Then through the years, we acquire many companies throughout the world. And then we become one large group worldwide called the Condair Group. And like I say, 75 years selling humidification equipment. And for the last 10 years, I would say also dehumidification. But still, humidification is our main focus, and that's what we're going to talk today about our webinar. We are present in 22 countries worldwide. We have in North America, specifically in the US, 50 reps. 120 rep agencies in the US and 50 worldwide. And we consolidate our production sites. So for North America, the products are manufactured in the Ottawa, Canada, and we still have some products will come from Denmark or Germany, but 90% of the products will be manufactured in Canada for the North American market. Over 800 employees also globally, probably around 200 in North America. So just to start about humidification, and for some of you that maybe it's a recent topic or is something new, what causes dryness specifically in cold climates and specifically like for the US and Canada. So you can see from those pictures, and I'm sorry, it's in metric. So humidity typically measured in absolute humidity or relative humidity. But if you see on the picture on the left, to give a representation, like a visual representation why this happens, if you bring outside air on the winter, for example, and then you heat the air inside, being with the furnace or the AHU, doesn't really matter, you are not changing your absolute humidity. So your content of water on the air is the same. So what happens is the relative humidity on the air will drop immensely because the air, when you heat the air, there is a lot of capacity to absorb moisture, right? If you look on the right side, what happens is when you have active humidification, so what happens is you bring outside air, you heat the air, but then you also add more absolute humidity to the air. So you're actually increasing your absolute humidity content, so your relative humidity also goes up. The relative humidity is important because that's what will govern the balance between materials or people and the surroundings. So the differential between humidity, right? So if its relative humidity is very low, then all the materials will have a tendency to release moisture to the air because to make like a moisture balance. If you increase your relative humidity, that difference will become lower and lower, and the tendency to release moisture will be much lower. So you can see in the bottom also what happens, like when you increase your temperature, keeping the same absolute humidity, your relative will dry. So what we want to do when you are humidifying, being for health or for processes, is to also increase your absolute humidity to keep a constant relative humidity. specifically for people, also what happens in your skin or your throat or your nose. If it's very dry outside, the relative humidity is very low, your body tends to release moisture to the surroundings and then dries out your body. So now I'll pass to my colleague Will for the next slides.
Yeah, thanks, Nuno. So there's a few different ways that we can humidify. You know, the more traditional way is what we call isothermal, or using steam systems. And what we mean by that is we are actively putting energy into the system to boil water to drive that phase change from liquid water to vapor. So that's electricity, that's natural gas, propane. We're boiling that water to drive that phase change. The products that we'll look at today, or the technologies that we'll look at today, are relying on energy that's already in the air. So that's either atomizing the water or evaporating that water. But because we're using the energy that is already in the airstream, it's a bit more efficient in that we get some cooling with that as well. And much more efficient than, you know, traditional steam humidification, especially for large humidification or cooling loads. So just looking at that, if we're looking at that on a psychrometric chart, you know, an isothermal process or the steam systems, we assume that there's no temperature change between the entering air or the leaving air after the humidification system. So that would be the red line on the psychrometric chart. So effectively just following the temperature straight up, but we are increasing the humidity within the space or adding moisture to the space. With an adiabatic process, or, you know, when we atomize or evaporate water into the air, it's effectively a constant enthalpy process, but for kind of back of the napkin calculations, we can assume it's a constant wet bulb process. So that would be the blue line where we're, you know, kind of going diagonally. While we're increasing humidity, we are also dropping the temperature as well. So that's a really important fact to keep in mind when we look at these adiabatic systems versus isothermal. If you don't need that cooling effect does need to be offset with supplemental cooling, so either preheat or reheat. But depending on the size of the system and the evaporation load, you know, it still may be more efficient to do humidification or cooling with an adiabatic system compared to a more traditional isothermal system. So the products that we'll look at today are focused really on our adiabatic products, but as Nuno mentioned, you know, Condair has a full portfolio of humidification and dehumidification systems as well. So whether that's you know, the traditional isothermal steam systems or the adiabatic systems, we do also have a residential line, and then as Nuno mentioned, we also do dehumidification and drying systems, and then across all of those we do support them with water treatment systems as well, so reverse osmosis or deionized water package systems as well.
Thank you, Will. Yeah, so we'll divide for the rest of the webinar. So we'll have a first section about IAQ, and then most of the rest of it will be on the retrofits going from steam to adiabatic, and how can we improve our energy consumption, our footprint, and also our total cost of ownership. And then we have some examples at the end that we did some retrofits where I can show you the savings. So talking about IAQ, so for humidification, humidification was a topic, but was never like pushed that much until recent years. So people always know there was comfort issues, well-being, but the buildings always focused mostly on the energy and the maintenance, and then humidification was always seen as something that there is a lot of maintenance, it costs a lot to run because mostly it was steam. So people want to be away from steam. But nowadays, with all the adiabatic technologies, cold water systems, and all the developments that we did for those technologies, you can have humidification in buildings, and with still a lower cost and lower maintenance. So that was always one of the big issues. Was for 30, 40 years, maintenance was always like synonymous with steam systems, and there was always like leakage and steam hose and steam piping. So people didn't really like to install. So they focus, like the facilities people always tend to focus on the building and forget about the people in the building. And I think after when there was COVID, people start to study more and bring old studies about the effect of humidification or the effect of relative humidity on virus, being not only COVID, but like influenza, SARS virus, common colds. And they start to realize that if you have a good humidity control on the building, there is less people getting sick on that building. And the recommendation has always been, and is still today, 40 to 60%. There will be some cases where you cannot have 40%, especially like Midwest, Canada, if it's very, very cold outside, and especially if the building is a bit old, and then you have to drop to 30 or even 25% sometimes, but still better than nothing. Especially, for example, in Canada, you can have cold like January, February, where I've seen like sometimes like 6, 7, 8% relative humidity inside the building. So even if you can only do 30%, that's still better than nothing. But that's something like people always knew, and people feel even when you sleep at home, right? So if it's dry, I think there is a lot of attention now, not only for the prevention of like artwork or the building or the wood, but also for the well-being of the people, for the discomfort, for like sore throat, sore eyes, especially if contact lens, for example. And I think there is a big push, and now with our new products, our new Adiabatic portfolio, you can provide that to a building even as a retrofit. So even if you have a building without humidification, you can install an humidifier as a retrofit and fix that discomfort in the building. So like I was saying, the recommendation is always 40 to 60. That's where most studies have seen is optimal conditions for human health and human IAQ. Like I said, some buildings you might need to change a bit to the left, go for 30. But if your building is focused mostly on the left side, it means the concern is just the building itself and the maintenance and not the people or the absenteeism. And even if you save some money in maintenance, so you don't have to do maintenance for the equipment, then if you have more sick leave and more absentees, then it's going to offset all the savings you have, right? So that's something, sometimes the left arm doesn't talk with the right arm, but absenteeism typically will cost much more than any maintenance you have to do in the building. There is a very old chart that you can see from the 80s. You can see on the left, and you can also see from more on the health perspective, for bacteria, virus, mites, infections. If you see, like I said, the 40 to 60, you can see the Sterling chart is to where the optimal range is. So this is something when you're designing a new, especially for designing a new building, also you should focus at least to be on the 40% throughout the winter, or if you are in a hot area and dry throughout the year. Just to give you an example, so for example, if you do a simple calculation and say, okay, the average is between 45 to 70K salaries per year, and then you calculate what's the CFM per person and the cost of humidification, you can see that typically one sick day, and of course depends on the locations, on the industry, but will cost between $170 and $260 to $270 a day for a company. And typically, and this is like for like I said, an average, it depends on the location, but just to give a good average of what we do day to day, it will cost you usually 8 to 10 cents to humidify per day per office employee in a typical office occupation. So you can see you can offset, even if you pay 8 or 10 cents for a full year, it's still cheaper than have 1 or 2 days of absenteeism with less sick leave. Of course, some people consider this very general and very average, but gives an example at humidification cost when you divide per the numbers of employee, and typically a large office building have multiple occupancy for floors, still much, much lower than where people take, even if it's just 1 or 2 extra sick days a year per office. And now, just to give a little introduction on IAQ, now I'll go to the retrofits, and this will, my colleague Will go through the Adiabatic portfolio. And this is products we are seeing a big push both in North America and Europe, because way less energy, less maintenance, so our total cost of ownership is much lower than steam. And the advantage of this technology is you can do easily retrofits. So even if you have buildings without humidification, or if you have buildings with old steam boilers or steam injection, you can retrofit with technologies like this. And typically your payback is 2-3 years or even less. And not only that, we also talk at the end, now we have rebates and incentives from the state authorities. So for example, if you have old like humidification systems that are not very energy efficient, if you install adiabatic technology, you can get large rebates from utility companies or even the state official authorities. So that's something really interesting and something we have been seeing a lot in the last 2-3 years. But I'll let my colleague Will go through the technologies. And like I say, if you have any questions, just write them down on the questions and we'll read them at the end.
Thanks, Nuno. Yeah, so the technologies that we'll look at today are, of course, our adiabatic products. So where we are evaporating water directly into the air, we're using the energy that is already in the air to drive that phase change. So there's a few different ways that we can do that. So what we call or classify as HVAC or ducted applications would be our, ME evaporative system, the high pressure atomizing system, and then we have a fairly unique system which we call the DL, which is a kind of a combination of the two with a low pressure atomizing system with an evaporative media downstream. Now, all of those would go inside of an air handler, a makeup air unit, or inside of a supply duct to the space. Now, the other way that we can do that is if you don't have a forced air system or a ducted system, we can do that as a direct room system as well. So that is where we would directly atomize or spray water into the air for the space that we are trying to humidify. And then, of course, as I mentioned, across all of those, we do provide water treatment as well. So a key thing to remember here is for all of these technologies, except for kind of the ME system and the B500, where we're evaporating water on wetted media, anytime we atomize the water, we do have to make sure that we pull those minerals and other items in that water out so they do not precipitate out when those water droplets evaporate. So if you don't have treated water on site, but you are considering an atomizing system or an ultrasonic unit, just keep in mind that you do need to treat that water beforehand. So just high-level overview, as I mentioned, HVAC applications, we are installing the humidifier or the adiabatic system directly in the supply air system before it gets to the conditioned space. So traditionally, it would go inside of an air handler or in some cases inside of the ductwork as well. But generally, these are being installed inside of an air handler that is supplying a specific zone or potentially multiple zones as well. The other way to do that is with direct room systems. So here we would have a central, for example, pumping system, and then we can pipe water and distribution systems to individual rooms or individual zones and humidify those zones directly within the space itself. So the first technology that we'll look at here is a technology that we call the ME, or a product that we call the ME system. The principle of operation has been around for ages and ages. You've probably heard the term swamp cooler before. We don't really like that term because it always has a lot of negative connotations with it in terms of hygiene and maintenance, but the principle of operation is the same. We effectively take potable water or treated water, we pass that over a wetted pad, and then the hot, dry air goes through that pad. All the evaporation takes place within the pad itself, and then we have cool, humidified air downstream from that. So with all of these systems, every pound of water that we evaporate is about 1,000 BTUs of cooling. So just something to keep in mind there. But in terms of operation, water quality, install, this is probably the most basic system that you can use when we're looking at adiabatic. The nice thing about it is because it's an evaporative pad system, we can use any type of water. So as long as it is drinking quality water, you can put the water through the system. And because all of the evaporation takes place within the pad itself, generally for a retrofit application, we don't quite need as much room as we would with, for example, a high pressure system that we'll look at later on. The next technology that we're looking at here, and again, this is going to be a very high level kind of 30,000 foot view of the technologies. By all means, if you are interested in learning more about these technologies, reach out to Nuno or myself, and we can certainly set up a technical discussion call and go over these in a bit more detail. But we just want to give you a high level overview of the differences between these different technologies and some of the requirements or design conditions considerations. So the other technology here is a high pressure atomizing system. And in this case, we are spraying water at about 1,000 PSI directly into the airstream. So you can see it here. We would typically have a main high pressure pump station with or without integrated reverse osmosis. We would have inside of the airstream a nozzle grid and a mist eliminator. And there we would be actively spraying the water to control humidification or cooling levels. Now, the thing to consider here is because we're actively spraying the water, we do need some time for that water to absorb into the air, evaporate into the air. So generally, we try and design around a 5-foot minimum duct section or air handler section to achieve a decent amount of evaporation. We can go as low as about 3 feet, but in those cases, we're probably wasting 50, 60, 70% of the water that we're spraying into the air. So just something to keep in mind for retrofit applications. This one may or may not be as ideal as some of the other technologies that we'll look at simply because of the airway length requirements that we need for absorption. So just to give you a quick overview here, actively spraying water into the air, the mist eliminator acts as a droplet separator, and we do get some post evaporation off of it as well, but all of that water is contained ideally within that 5-foot section. The other technology that we'll look at here that is effectively a combination of those two previous products is what we call the dual or the hybrid system. So this is a low pressure atomizing nozzle system with an evaporative media downstream. So the big differences here are we are atomizing the water at about 100 to 150 PSI compared to about 1000 PSI with the high pressure system. And then downstream, instead of a traditional glass fiber or polyester media we would have on the ME system, we have a fairly unique ceramic media, which is a porous tile that you can see here in the photo that is effectively good for the life of the unit, but that acts as a droplet separator and post evaporator as well. Now, because of the design of this with two modes of evaporation, the lower pressure and the ceramic media downstream, we can actually install that in a 24 to 36 inch section, with some requirements for clearances upstream and downstream. But the big difference there between the high pressure system is we're able to shrink that absorption distance down from 5 feet down to 24 to 36 inches. So for retrofit applications, this would be a really good product to start looking at if you've got, say, a short absorption manifold or a steam grid inside the air handler that maybe has 4 to 5 feet of install length with that steam grid in there. So really, really good product here to look at for adiabatic retrofit applications inside of an air handler. So moving away from the in duct or in air handler applications, we'll look at some high pressure in space. So we effectively use the same type pump system that we have as the high pressure in duct. So we have what we call our MLP system, which pressurizes the water to 1000 PSI. But in this case, we would have distribution heads mounted directly in the space that we're trying to humidify or cool. So you can see that we've got a few different types of heads here. The video on the top, I believe, is our flex nozzles. So those are just atomizing nozzles, the same ones that we use for the in duct high pressure systems. The bottom video is of a solo or an atomizing system with fan assist as well. So if we're in a smaller space or more confined space where we need to get that water absorbed in much smaller clearance, we actually add a fan onto that as well just to help increase the airflow. Now, the nice thing about the high pressure in-space systems is we can do multiple zones as well. So if you have a manufacturing zone and you have an office space and you want to humidify those, each with different set points and control each one individually, we can do that with a single pump station, provided the capacity is within that, the capacities of that pump station itself. But the nice thing is we can mix and match different technologies or different zones with the single system. The next technology that we'll look at here is a smaller capacity in-space system, and it's our US series or ultrasonic humidifier. So the way that this works is we have inside of that cabinet a series of piezoelectric transducers that vibrate at an ultrasonic frequency. So those work by breaking the surface tension of the water and generating a really, really fine mist. We take that mist, and on the top of that unit, you can see we have a blower or a fan pack that will just take that mist and blow that directly into the space. With these, it's very critical that you do have RO or DI water, because if you're just put potable water through that system, the transducers will actually clog up as well, and you'll start losing capacity and have a bit more maintenance there. These are in-space units only, so we don't have the ability to put these in duct. And in terms of capacity, they start at about 20 pounds an hour all the way up to about 40 pounds an hour as kind of the maximum high-end capacity for a single unit. And then the last technology that we'll look at here for in-space is a small little packaged mobile evaporative system, what we call the B500. So it's a wetted pad system, just like the ME, but in this case, it's a standalone system. You can roll it into a small office or a room if you want to humidify. Maximum capacity here is about 5.7 pounds an hour. We do have options for supply water and drain water lines to be connected to it to try and automate that a little bit. The other option is kind of a manual fill option where you just have to periodically add water to the system. But we do include a wireless humidity sensor and a remote for that to try and control that and make it a little bit easier to operate.
Thank you, Will, for that explanation of our adiabatic technologies. So thank you, guys. So those technologies, I would say, for retrofits, especially for energy efficient retrofits, for decarbonization with the right technologies that you can apply in your building. I'll give you an example we did here in Otto. So Otto is where we have our main factory for North America. And we have a building downtown. It was a relatively old building, had 470,000 CFM units. And we had a resistive electric steam humidifiers, quite old technology, 200 pounds each, so 800 pounds total. And then what they decided to do is to retrofit that steam with the ME. You can see that picture on the right. That blue light you actually see on the bottom is a submerged UV for disinfection. So like I said, our technologies are very, not only energy efficient, the adiabatic technologies, but also very hygienic. So that's also one of our priorities. And you can see, so with all the investment, both for equipment and for contractors, for the installation, the payback was only 2 years. Not only that, they had a rebate from Hydro Ottawa for $80,000 for this installation. So this system will probably last at least 15 years. So after 2 years, everything will be a payback for them compared with steam. And Ottawa is a very, very cold city. So some of you guys know. So even with these cold climates, the payback is there for adiabatic technologies. So also one of the things is if any one of you guys have a project or you have concerns that there is an issue with the weather or a payback, you can give us the project or give us the idea of what you want to do, and we can run an hourly simulation for you for the location and for the way the building operates with economizer cycles or mega pair, etc. Then we can give you a document with all the analysis and the payback, and you can use your local utilities. So that's all the support, engineering support from Condair. So when you have a project, and actually many states will know people that work in the state and have rebates already in previous projects. So you can also put you in contact with those people so you know how did they get a rebate before. And another example was in Indiana. That was a warehouse we did there. And then we did the comparison between, this case was the DL. You can see the one that Will was talking about, the hybrid with ceramic plates. And we did a comparison hourly by hour on that location for the design there on that building. And then we compare between the DL, the gas, so gas-fired humidifier, and then also EL. So EL is the electric steam humidifier. And you can see, typical for steam humidifiers, the initial cost is always lower than the adiabatic humidifiers. But then when you look on a 10-year operation, the total cost of ownership, you can see typically electric will always shoot up and be way more expensive to run. So your capital is always, even if it's lower up front, if you can show to the end user, to the owner of the building, look, even if your capital is lower this year, then every year you have a bill you have to pay and it's quite high. So that's one of the things, or even if people have old steam, like I was saying, they can retrofit with some of the adiabatic technologies, and typically the payback is actually very low, especially if it's a cold climate where they run the humidification for 3,000 hours a year, let's say. They have a big season. It's very, very low. And especially if you have already like treated water on site, being RO or DI or ultra pure water, then your payback is even lower because you don't have to invest on that part of the equipment, right? Also, just to give you one reference, there is a website, dsireUSA.org. You can go there and put your zip code, and you can see, so this is always updated, what rebates or incentives there are for this type of HVAC applications on your location. And typically more and more states are on board, especially with the energy crisis we have seen in the last since the Ukraine war. It's like people try to reduce your energy consumption footprint on the buildings. So there is a lot of incentives also from utilities, and humidifiers in many applications are one of the energy hogs there. So that will be a perfect time to retrofit and change for a more energy efficient technology. So that was our webinar, right on time, 30 minutes. If you have any questions, you can email me or Will. We'll share this presentation as a PDF with all of you guys. At the end, you can see our emails. If you have any questions, any project, any ideas you want to discuss, we're always happy to talk with you. We also travel a lot, so we do a lot of lunch and learns. So if you guys want us to go over to your office and present in more detail specific products and help you guys with the design, we also do that. But we're always here, always available. If you guys have any questions or just want to understand more about the technologies, the downsides, upsides, etc., you can also contact us. Like I say, we'll share this presentation as a PDF today. There will also be a recording you can access later on. And now if you guys have any questions, you can just write them down and we'll be happy to answer them. And thank you so much for your time today on the webinar. So one question maybe for you, Will, you're talking about the products, is can we use ultra pure water with all the adiabatic humidifiers?
Not with all of them. So on the evaporative media system, the ME, we do have kind of a low end requirement of about 5 microsiemens. Our only concern there is on some of the glues that we use to hold the media together or bonded, and then just on some parts of the pump as well. Other than that, on the DL system, I believe it is also 5 microsiemens as well. Main reason for that is on the DL system, we have a fairly unique hygiene feature that is called the Hygiene Plus system. So that is an active silver ion dosing system, and we do that through kind of electrolysis of silver ion plates, and we do need kind of a minimum conductivity in that water to be able to use that Hygiene Plus system. But with the HP atomizing systems, yeah, absolutely, we can use kind of ultra pure kind of DI water, but there are some water quality limitations. It just depends on the technology.
Thank you, Will. Another question was if we have induct ultrasonic humidifiers. Not, so like Will will say, for ultrasonic technologies, we only have in space. And the reason why we didn't develop induct, and it will be quite easy for us to do it, was because we believe the DL and is a much better technology to have induct. Also because sometimes when you have induct equipment, the maintenance is not as often as in space because you don't see it. So for ultrasonic technologies, we only have in space small loads, so small units. So we do not have induct technologies for ultrasonic. Another question. So how do you control humidity levels during cold nights to prevent condensation? So that's a good question. So condensation is always one of the topics for humidity, right? So typically what many people will do, and depends a lot on the locations, is they'll modulate down, so they'll set back your humidity when it's very cold outside. So they have the temperature outside, especially with our new equipment, we have IoT also, so that's quite easy. And most of the humidifiers will be connected to BACnet or to BMS. So what will happen is you typically will decrease your set point, or even like do not humidify during the night. And then before people, for example, go to the office or application, you start humidify. But that's always, and that's what I was mentioning, if you are in a very cold climate, you might not be able to even do 40% if it's an office. Industrial is typically a different design approach, but condensation is always an issue, and that's always needs to be something building by building, basically based on the location and experience. But you might need to put a setback on your control when it's very cold outside. It's like, especially in, like I said, Midwest or some locations in Canada, and then you need to modulate your set point based on the temperature outside. And that's the same when you do at home. So if you have a house humidifier, like a small steam or a bypass in your furnace, typically you have to set back based on if it's very cold outside, so you don't get condensation on the windows or cold vapor barriers. Another question, maybe that's one for you, Will. If the high pressure skid, we can do hybrid, so we can do both in space and in deck with the same skid in the same location.
Yeah, absolutely. That's a great question. So I did mention you can do separate zones with the pump station, but what we can also do is in duct and in space humidification or cooling with a single pump station as well. So that one I believe is a bit of a special. So you know, if we have an application like that, you know, we work closely with our applications team to put that system together. But absolutely, it is something that we have done before, where you can, you know, mix and match different you know, spray heads inside the space, and then also have a high pressure atomizing system inside of the duct or the air handler feeding the zone as well.
Thank you, Will. Another question was how long you guys take to do energy analysis. Yeah, usually it'll be like, I'll say 2 or 3 days. So it depends if we have all the data. Sometimes the issue is when it's a new project, sometimes there's a lot of data missing, like the sizing, like that depends a lot for the investment, right? If it's a retrofit, typically we know what is needed, so we have all the dimensions, the loads, etc. So that will be a very quick turnaround. So I'll say probably 48 hours. Usually the thing that influences the most the turnaround for our tools or for our documentation in this case will be missing information. But and then sometimes what we do is we do some assumptions, then we write down the assumptions, and then we have to revisit later on when the project is in a different phase. But typically, if it's a retrofit, most information is available. Sometimes it's so old that we have to go by pictures and like people on site, and then we still have to do some assumptions. But usually, it's not doesn't take that long. Another question, maybe you can answer, Will. Can we wash the ceramic plates on the Condair DL?
They can be washed. I know some people have you know, kind of steam cleaned them as well. Generally, if the water quality is maintained and the air filtration is maintained, you shouldn't have the need to wash that ceramic, but it can technically be done. What you would typically see in operation is, because of the silver ion dosing system, it also disinfects the it not only disinfects the water, but disinfects the supply lines to the nozzles themselves, and then also disinfects the ceramic plates as well. So what you'll generally see in operation is those ceramic plates will go from a white to kind of a silverish grayish color, and that's just the silver you know, adhering to the ceramic plates. So technically they can be cleaned, but you know, theoretically they shouldn't need to be cleaned, provided that water quality and the air filtration is maintained upstream.
Okay, everyone, I think we're right on time, so 1:40 Eastern time. So if you have more questions, just send an email to us. We'll be happy to answer. If you want to have a call, Teams call, or you want to visit or lunch and learn, reach out to us. Like I said, we will share this presentation. Our contact is at the end. If you have any project, like I say, reach out to us. We're always here to help. We're happy to help. Even if no project, you just want to learn more about technologies for the future, feel free to reach. We're always here. Again, thank you so much for your time. I know everyone is super busy. I hope we had a good webinar and took some information with you that we can use for the future. Like I say, have a great day. And if you have any questions, just reach out to us, and we're always here to help you guys. Have a wonderful afternoon, and thank you so much for your time again.
Thank you, everyone.